The answer on this one is B. Alright, the answer to this one is D. Answer to this one should be A. Answer to this one should be C. Answer is A. Answer on this one should be D. Here's a quick review. Just say the answer out loud. 4x. 12x to the fourth.
No.
3x over 2. 3x over 2. 20x to the 7th. 4 over 3, yeah. 12x to the 4th. 1 over x. 1 over 2x squared. 3. Pick a number from 1 to 10. Winning number is 5. Objective today. We're going to do factor by grouping in order to build up to this objective here. Example 1. The directions are to simply factor. However way you can factor it, that's how you have to do it. But in this case, it's going to be factor by grouping, what we're going to study for the next couple of days. Pick any two terms in there that have something in common that you could factor out of them. And you can start at any two terms and test it out. If it doesn't work out, then you can go back and try again. I'm going to pick 18a squared and 30x, just to use the front and the back. First thing you should do is write those two together, put parentheses around them, and then go look at your other two terms. If you have a plus sign in front of your first term for the second set, then you just put a plus sign there and then parentheses and recopy it. When the first term is negative, that's when you have to do something different. Well, in the first set that I've picked out there, I can take out a 6 and an x. So I'll take out 6x, and then what do I multiply 6x by to get back to ax squared? It'd be 3ax. And then 6x times 5 would give me 30x. Now over here on this side, I have a 20x to the third and a 27a. What do they have in common? Nothing, so I'm stuck. I can't go any further. That doesn't mean you write not factorable. It means you go back and start the problem again. So just draw a line here and then start over again. Instead of picking those first two terms, what two terms could I pick now? Okay, so we'll pick 18ax squared plus 27a. And the other two sets are positive, so there's no need to worry about a sign. So plus 20x to the third plus 30x. Now what can I take out of the first set? Higher than that. 18 and 27. You can take out a 9. And what else? I can take out a 9 and an A. So to multiply 9a by something to get 18ax squared, that something must be
2x squared.
2x squared, and then 9a times what is 27a? 3. So now over here, 20x to the third and 30x, what do they have in common? 10x, and we can come up with a 2x squared, and then plus 3. Do I have the same quantity here and here?
Yes.
So that's it. You write it once in a set of parentheses, and in the other set you use what was on the outside. 9a plus 10x. And that's the answer. Example 2. Give me two terms that you think I could start with to factor by grouping. 2ab and minus 2ax. Okay, we can do that. And if we had this sign here, since you have your first term that is negative, you have to put the minus sign out here, set up your parentheses, and change the sign of everything inside that circle. So instead of putting in minus 3b, I'm putting in 3b. And instead of 3x, it's minus 3x. If you can multiply that out by negative 1 and come back with what's up here, then you did it right. So a negative 1 times 3b and negative 1 times a negative 3x would take us back to the original spot. What can I take out of 2ab and 2ax? I can take out a 2a and be left with b minus x. What can I take out of 3b and 3x? Just 3, and be left with b minus x. So I have the same quantity there and there. So just write it once. And then what was on the outside of the parentheses, including the sign, go in the second. For the practice problem, I am going to group, let's see, you can do a 7 out of this and this, at least a 7a. So I'll give that a shot and make it 56ax squared plus 35a. But for the other two terms, my first one's going to be negative, so I have to put minus, and then 32 x to the third plus 20x. I must change that sign because of this. Okay, next I can take out a 7a from the first set and be left with 8x squared plus 5a. And on the second set, I can take out a 4, looks to me like a 4x, and be left with 8x squared, and then plus just 5. Alright. Alright, so we end up with the same expression here and here. So it turns out to be 7a minus 4x in one quantity, and in the other 8x squared plus 5 in this one. This one should have been 3x over 2y. Answer to this bonus is 3y to the third over 2. Answer to this bonus is 25x to the 6th. So the first 7 people with this answer. 2 to the 3rd power is 8. Because it's 2 times 2 times 2. It's not 2 times 3 for 6. And then for an exponent raised to an exponent outside the parentheses, you multiply those. So it should be 8x to the 6th. You would not have a 5 out here from 2 plus 3. It's 2 times 3. Try this practice. Alright, so I'm going to pick 2 terms here, and it looks to me like since I can get a 6 out of each of these and a 7 out of those, I'm going to give that a try first. So it's 30ax squared plus 36x to the 3rd. Put that in parentheses, and they're all positive, so the signs won't matter this time. 35a plus 42. Alright, so I can take out a 6x squared on this one and get 5a left over, and then 6x for this one. And then over here I can take out a 7 from each of these and be left with a 5a and then plus 6. Now, do I have the same terms in here and here? No, I don't. And it's not a matter of me writing in an extra variable this time that I erased on the other slide. So we just draw a line and try again. So instead of grouping the first 2 and the second 2, let's try the first and the last. How about 30ax squared plus 42? And then the middle 2, there should be a plus in there. There we go. 36x to the 3rd plus 35a. If I factor out on the first one here, I can take a 6 out of both of them and be left with 5ax squared plus 7. And then over here take out nothing. I can't take anything out of those. So the first 2, second 2, first and last and middle 2 do not work out. So what else can I try? 30 and 35? Alright. We can give it a... I'll work it out anyway. We can do 30ax squared plus 35a. And then on the second part we would have 36x to the 3rd and plus 42. So over here I can take out a 5a and be left with 6x squared plus 7. And over here take out a 6 and have 6x to the 3rd plus 7. Do I have the same quantities? No. Answer to this one is not factorable. X to the 3rd and x to the 6th, when you multiply them together, it's x to the 9th. You add exponents when you multiply variables. They're the same. And 4 and 5 would be 9 as well. Don't forget when you have exponents over exponents, and this one is over this one, because if you multiplied together, they would be straight over top of each other. So you can cancel them out diagonally and just be left with an x on the top. 4 minus 3 is 1, so x to the 1st. And then the same thing with the y's. Y to the 7th and y to the 6th. Just a y. So the answer is xy. At first glance, you notice you have a minus sign, a square, and a square, but this is not 81, that's 18. That's not a perfect square. So you can't do a difference of 2 squares. But you can factor out a 9 from both of them and be left with x squared minus 2y squared. And that's all you can do.
I had that.
Fast multiple choice. 2 to the 3rd power is 8. X squared to the 3rd power is x to the 6th. And then multiply by x to the 4th to the 2nd, that's x to the 8th. So 8x to the 14th. The answer should be C. 2 to the 2nd is 4. X to the 2nd is x to the 4th. And y to the 2nd is just y to the 2nd. 3 to the 2nd is 9. X to the 2nd is x squared. Y to the 2nd is y to the 4th. 4 and 9 are 36, and once you get to that point, it'll be 36x to the 6th, y to the 6th. No other option in there has 36. Example 3. What two terms should I pick out? Yeah, 9, 9, 10, 10. That's clearly obvious. So what can I take out of the first two terms? 9x squared, yeah. So I have 9x squared and be left with an a minus x. And since there's a plus sign in front of the 10, we can just work this out instead of having to change signs. I'm going to take out what from these last two? 10 and be left with what? A minus x. Do I have the same quantity? So it's 9x squared plus 10, and then not plus, it's multiplication, a minus x. There we go.